Let us now discuss about the BFS algorithm. Breadth first search BFS algorithm traverses a graph in a breadthward motion and uses a queue to remember to get the next vertex to start a search. When dead end occurs in any iteration, BFS is the most widely used traversal algorithm used in industries for various purposes. BFS follows a certain workflow which is visualized in the diagram on the slide. The BFS algorithm uses queues which follow the FIFO policy. The algorithm follows a three-step procedure and each step is repeated until the queue is emptied. The rules are as follows. Rule 1. Visit the adjacent unvisited vertex. Mark it as visited, display it and insert it in a queue. If no adjacent vertex is found, remove the first vertex from the queue. Rule 3 is repeat Rule 1 and Rule 2 until the queue is empty. There is a pseudocode which explains the functioning of BFS easily. In the first step, we begin with the functions. Firstly, we define an empty queue and mark all the status of nodes as unvisited. Then we add the start vertex into the queue. Further, we use a while loop which works until the queue is empty and performs iterative operations. Here we first delete item from queue and set to U. Then we display the vertex U. Further, we use an iterative condition using a for loop where we perform operations to all vertices 1 adjacent to U. Here we first check if the element at the vertex is visited or not. Then mark that element as temporarily visited and then add it to the queue. Further, we mark and express done with the for loop. Mark U as completed and final done for the while loop and end the procedure. Here is a typical example of a BFS wherein we followed the three-step procedure for each iteration. In the first iteration, we get the value 10, followed by 20, 40, followed by 50, and finally 30 and 60. There are various applications of BFS, some of which include shortest path and minimum spanning tree for unweighted graph, peer-to-peer networks, crawlers in search engines, and social networking websites.